Optimization example 4. A corridor has a 90-degree bend in it as shown. Two workmen are trying to maneuver a long rod around the corner holding it horizontally. What's the longest rod they can actually move around that corner? We can see the width of the corridor here is 3 meters and here is 4 meters. So what I'm going to do is just form a couple of right-angled triangles here, and I'm going to call this angle theta, and then this angle is going to be theta because these are going to be similar triangles. Now let's call that A and call that B. I know that's 4 and I know that's 3 just there. And so the longest rod is going to be A plus B. So if we look at, so this angle is theta, and that's the opposite, and that's the hypotenuse. So I can say that sine theta is equal to 3 over b. And that means that b is equal to 3 divided by sine theta. Now, here the 4 is the adjacent. So we can say that the cosine of theta is equal to 4 over a. And so a is equal to 4 over cos theta. So the overall length is going to be 3 over sine theta plus 4 over cos theta. To find the maximum for L, we need to differentiate. So we're going to do dL d theta. So we've got negative 3 sine theta to the negative 2 multiplied by the differential of the inside function, which in this case is cos theta. Take away 4 cos theta to the negative 2 multiplied by the differential of the inside, which is negative sine theta. So in actual fact, that's going to come to negative 3 cos theta over sine squared theta plus 4 sine theta over cos squared theta. Now, we want that over a common denominator, and the common denominator would be sine squared theta cos squared theta. So this sine here needs to be multiplied by sine squared. So we're going to have 4 sine cubed theta, take away, and here multiply top and bottom by cos squared, 3 cos cubed theta. So for dL d theta to be equal to 0, we need 4 sine cubed theta take away 3 cos squared theta to be equal to 0. So that means that 4 sine cubed theta is equal to 3 cos cubed theta. Dividing both sides by cos cubed theta gives us 4 tan cubed theta equals 3. So tan cubed theta is equal to 3/4. Therefore, tan theta is going to be the cube root of 3/4. So we can get an angle for that. So what we need is the calculator. And let's bring that in. And so we need the inverse tangent. And we had a cube root button, which was just there. And so the cube root of 3/4. And that gives us 42.3 degrees, or we'll use 42.257. Let's just say that's 3 decimal places. And therefore, the length is going to be 3 over the sine of that angle plus 4 over the cosine of that angle. So we've got 3 divided by sine of my last answer, but I think I've actually played with the calculator a bit in the intervening period, so I better just type that in and then add 4 divided by the cosine of the previous answer, 42.257. And let's press equals on that, and that gives me 9.87. So I'll call that 9.87. Correct, 2 decimal places.